As humans, we've always been fascinated with the unknown. From the vastness of the universe to the depths of the ocean, we've always sought to understand what lies beyond our immediate reach. One of the most mysterious and captivating phenomena that scientists have been studying for decades is radio signals emanating from distant galaxies. These signals, which radio telescopes around the world have picked up, carry with them the potential to unlock some of the deepest secrets of our universe. They could reveal the presence of extraterrestrial life, provide clues to the formation and evolution of galaxies, and even shed light on the fundamental laws of physics. But despite years of study, we're still grappling with the mystery of these radio signals. What causes them? Where do they come from? And what do they mean for our understanding of the cosmos? Strange sources have been transmitting radio signals to Earth for years, and scientists have now traced some of their roots, and they were astonished by what they discovered. Now, astronomers use NASA's Hubble Space Telescope to pinpoint the locations of 5 deep space signals known as fast radio bursts, or FRBs. These enormous explosions produce as much energy in 1,000th of a second as the sun does in an entire year. Since the first FRB was discovered in 2001, over 1,000 have been recorded, but they're famously difficult to monitor because they vanish instantly and leave no trace. Until now, only 15 have been linked to individual galaxies. Scientists want to know where these powerful pulses are originating from so they can figure out what cosmic events are causing them. Or, beings. Researchers using Hubble's Camera 3 were able to locate 5 out of 8 recent FRBs to their host galaxies and the types of places they originated from in the new study, which was to be published in the Astrophysical Journal. The spiral arms where stars originate are a feature of all of these distant galaxies. Some of the arm structures were more tightly wrapped than others, indicating variances in star distribution. The photos taken show that FRBs are most likely not produced by the galaxy's youngest, most massive stars. According to astronomers, the flares aren't caused by the violent deaths of these young stars or the merger of neutron stars. They also don't originate from dwarf galaxies, which scientists previously failed to rule out. With each new finding, astronomers are narrowing down the possible explanations for these odd signals. Wenfei Fong, a team member, stated that since they don't know what causes FRBs, it's critical to use context when they have it, and this method has been quite successful in detecting the origin of other types of transients, such as the supernova and gamma-ray bursts. Hubble also played an important part in that research. The findings support the theory that FRBs are produced by the bursts of young magnetars, which are neutron stars with tremendous magnetic fields. Scientists refer to them as the universe's strongest magnets, 10 trillion times more powerful than a refrigerator door magnet. Fong continues to explain that magnetars are highly unpredictable due to their strong magnetic fields, and the FRBs in this case are likely to be caused by flares from a juvenile magnetar. Huge stars evolve into neutron stars, some of which are extremely magnetized, resulting in flares and magnetic processes on their surfaces that can emit radio waves. The galaxies seen in the study existed billions of years ago, meaning scientists were looking at them when the universe was around half its current age. Many of them are as large as our Milky Way galaxy, which is likewise a spiral galaxy. All galaxies are between 400 million and 9 billion light-years away from Earth. This may be one of the most interesting fields, and finding these localized events is a critical piece of the jigsaw, and a very distinctive puzzle piece in comparison to previous efforts. It's not the first time we, as humans, have received signals from outer space. Astronomers discovered a celestial object emitting massive bursts of energy while measuring radio waves across the universe, and it's unlike anything they've ever seen before. The rotating space object, discovered in March 2018, emitted radiation 3 times each hour. It became the brightest source of radio waves visible from Earth at the time, operating as a celestial beacon. Scientists believe it's either a massive neutron star or even a dead white dwarf star with a strong magnetic field, or it might be something altogether different. The lead study author, Natasha Hurley-Walker, an astrophysicist at the International Center for Radio Astronomical Research's Curtin University node, said that this object appeared and disappeared over a few hours during their observations. It was very unexpected, and it was eerie for an astronomer since there was nothing known in the sky that could do that. And it's really close to us, only approximately 4,000 light-years distant. It's there, in our galaxy's backyard. Tyrone O'Doherty, a PhD student at Curtin University, made the rare finding while using the Murchison-Wide Field Array Telescope in Western Australia's outback. He said it was amazing that the source he discovered last year was such a strange thing, and the large field of vision and exceptional sensitivity of the MWA is ideal for surveying the entire sky and identifying the unexpected. But what's left of a massive star's demise? Transients are objects that appear to flash on and off in space. ICRAR Curtin astronomer Gemma Anderson said that when researching transients, you're seeing the death of a huge star or the activity of the debris it leaves behind. Slow transients, like supernova, might develop over the course of a few days and dissipate after a few months. Fast transients, such as pulsars, are neutron stars that flash on and off in milliseconds or seconds. This new, tremendously bright object, on the other hand, only lit up for roughly a minute every 18 minutes. Magnetars typically flare in a fraction of a second, but this item takes much longer. He explained that this is a form of slowly spinning neutron star that's been theoretically predicted to exist, but no one expected to discover one this bright immediately. It converts magnetic energy to radio waves considerably more efficiently than anything else we've ever seen. The researchers will continue to observe the object to see whether it switches back on while also looking for indications of other similar objects. And if you thought that was all, there are even more interesting occurrences. According to space.com, scientists have recorded radio signals from a galaxy about 9 billion light-years away from Earth. This is the first time a signal of this magnitude has been received from such a great distance. The signals were identified by a unique wavelength known as a 21-centimeter line, or the hydrogen line, which is generated by neutral hydrogen atoms. According to an IISc announcement, the astronomical distance across which such a signal has been picked up is by far the greatest. This is also the first time that substantial lensing of a 21-centimeter emission from a galaxy has been confirmed. Atomic hydrogen is the fundamental fuel for star formation in a galaxy. It was explained that when hot ionized gas from a galaxy's surrounding medium falls onto the galaxy, the gas cools and creates atomic hydrogen, which subsequently becomes molecular hydrogen and finally leads to the birth of stars. Because of the enormous distance to the galaxy from here, the 21-centimeter emission line had redshifted to the 48-centimeter range by the time the signal reached the telescope. The 8.8 billion year look-back time for this source is based on the fact that the signal was sent from this galaxy when the universe was just about 4.9 billion years old. This identification was made possible through gravitational lensing, a phenomenon in which the light generated by the source is twisted due to the existence of another massive entity, such as an early-type elliptical galaxy, between the galaxy and the observer, greatly magnifying the signal.